Righty, good morning everyone again. That's a sufficient period, it's 9:32, close enough. We'll kick off with the actual real business of PyCon ZA, hearing interesting people tell us things we didn't know before that we'll learn from. Our opening keynote this morning for our conference is by Rudi Giesler, who has been working with Reach Digital Health for the last 8 years, creating open source solutions using Django and Python to help the country's most vulnerable citizens live healthy and empowered lives. As a side note, I did ask Rudi last night if it's Giesler or Giesler. Giesler it is. We're in Natal, we'll be English. If Reach Digital Health sounds vaguely familiar to you, or at least the work sounds familiar, they're the guys who were Precult, and something before that, I think. But anyway. Rudi will be talking to us about green coding, in other words, environmentally sustainable programming practices, a very important, very broad, and very interesting and sought after topic. So we thought we'd make a great keynote. That's enough from me. Rudi, over to you.
Thank you.
Oh, sorry, not quite. My apologies. I forgot one thing. For online attendees, there is a Discord channel per room. So under the channels, there's a main hall channel. Please put any questions you've got for Rudi in that channel. I'll be able to see those and we'll put them to Rudi at the end of the keynote. Similarly, in-person guys will take questions too, but that's easier. I'll bring you this microphone. Cool. Now I'm done. Thank you.
Thank you. Thanks for the great introduction. So I'm going to give a brief overview about myself, just to give you some background around where I'm coming from. I've been working at Reach for the past 9 years, creating open source software using Python, of course. I'm a principal engineer at Reach Digital Health, where we create mobile solutions to improve healthcare for those who need it most. Now, Reach is a non-profit organization based in South Africa, previously known as Precult.org, previously known as Precult Foundation, where we use existing technology to improve healthcare and create social impact. What I mean by existing technology is things like WhatsApp, SMS, USSD, sometimes web, things that people are familiar with, interfaces that people use in their day-to-day life. Improving healthcare, we're talking about lowering barriers to access, whether this is if people don't have time to go to a clinic and stand in a queue to get support for their healthcare, or whether they don't have the finances or transport. We want to lower the barriers to that access so that everyone can get proper healthcare. As well as supporting the health systems, we want to support the healthcare providers, as well as the healthcare workers, in order to provide the best care that they can. We also are big into innovation, but we use existing technology in new ways, and that's how we innovate. So we use these older technologies like SMS, which people might not think is innovative, but we use these in new and existing ways. And I find the best way to talk about and explain what we do is to give you some concrete examples of some projects that we worked on. The first one I want to talk about is called Mom Connect. This was a service over USSD and SMS, and later this expanded over to WhatsApp. The way the service works is when a mother presents pregnant at a clinic, they can get signed up to the service, and the service will provide them with maternal health information at the relevant stage of their pregnancy, and once the baby is born, for the relevant stage of that baby's age. So this will allow them to get messages and information that will help them make the correct decisions, and this is tailored towards where they are in their stage of pregnancy. It also gives them access to a help desk that's staffed by nurses, so if they have any questions, if they have things that can be answered and resolved over an SMS or over WhatsApp, then they can get that help without having to take a day off work, get money for transport, stand in a queue at a clinic. The next project I want to give a brief overview about is Young Africa Live. This is a WhatsApp service that aims to empower young people to explore and embrace their sexuality and make informed decisions on their health and well-being. Young Africa Live is where we first introduced a lot of tailoring and segmentation into the service so that people will get the correct information for their specific profile. So we can build a profile up of the user over time and then use that to give them information that's relevant to them, be able to find the correct information to the questions that they have. And finally, I want to give a brief overview of a project called Contact NDOH. This was over WhatsApp initially. This was around the time of COVID-19. This was our response to COVID-19. It started off as just a way for people to browse accurate information directly from the Department of Health, to have accurate and up-to-date information. There was a lot of misinformation swirling around on WhatsApp as well, and we wanted to provide a way for people to see and access accurate information around COVID-19. This also expanded to a feature on there we called Health Check. When in the beginning tests were not widely available, you had to have a certain specific set of circumstances to be able to get tested, and that was often confusing and often difficult to know what is the up-to-date set because it changed often. So you'll be able to answer on the service through WhatsApp a list of questions of your symptoms, and that would give you advice around should you stay at home and isolate, do you need to go out and get a test. And later on, we also expanded to when vaccinations were available, where you could register on WhatsApp or on USSD when we expanded the service over USSD as well to register for the vaccine to be able to receive it. So hopefully that gives a brief overview of Reach, what we do, what I do on a day-to-day basis, gives you some background around there. But today, I'm going to be talking about green coding. So just to give you a brief overview of what we're going to cover. Firstly, we're going to talk about why should you care? Why should you take the time and effort to come and firstly watch this talk and then take what you've learned and implement it in your day-to-day work? In order to do that, we're going to first look at what is running. What is the code that you are running, and what impact does that code have on the environment? The second one we're going to look at is where is it running? Whether it's running on a server, on a user's device, on a laptop, where does this code running, and what impact does that choice of where you choose to run it make? And finally, we're going to take a further step back and look at who is creating that code and what impact does that have on the environment. So in this talk, I want to give you a specific set of skills instead of solutions. This is a very complicated topic. The answers are often non-intuitive, and I think that the best solution differs widely according to the specific circumstances that you and your organization are in. So I don't think there's one clean answer that I can give everyone, but I'm hoping to give you a set of tools, some knowledge around the field, some basic knowledge, and a set of tools that will help you make the best decisions to have the biggest impact that you can. Some caveats: I do not have a degree in environmental science. I come from engineering and software development background, so I'll be relying on results of research and taking that and presenting it within the context of software engineering. So we'll have a look at the research, what the research says, and how we can apply that in our day-to-day fields. Second caveat, at JanuaryCon EU this year, there was a talk by Andrew Aikman titled Green Coding with Django. You might notice that's a very similar title to mine. This is where I was first introduced to this concept of green coding. And so I drew a lot of inspiration from that talk. I drew a lot of learning from that talk. But I wanted a talk that took a different approach to green coding. I wanted it to have the local context, the South African context, and so that's what I did. I put together this talk to kind of approach it the way I would want to approach it, as well as keep that local context. So to start off with, why should you care? I'm sure we've all heard and seen pictures and news like this, extreme weather events caused by global warming. These are all the kind of obvious reasons that you'd expect someone like me to stand up and talk to you about. So I'm not going to spend a lot of time going over these reasons. I'm going to talk about some of the reasons that you don't often hear. These are the Sustainable Development Goals for 2030. In 2015, UN member states got together and said, and had a look at what do we want to achieve by in 15 years' time, by 2030. What are the main goals, main issues facing humanity, or how do we want to solve them, and what do we want to achieve? These goals were agreed upon by 193 UN member states, including South Africa, and so all these member states committed to achieving these goals by 2030. At REACH, we focus mostly on goal number 3, good health and well-being. But today we're going to talk a lot about goal number 13, climate action. Now, we will touch on a few of the other goals. A lot of these things, you make an improvement on one area, it helps in other areas, but our main focus is going to be 13, climate action. A year later, in 2016, there was an agreement signed called the Paris Agreement. The main goal of this agreement was to keep global temperature rise below 2 degrees Celsius and to have 50% less emissions by 2030. Now, this is also an agreement that South Africa agreed with, signed on with the UN. So our government has committed to these goals and to climate action. And these goals won't be reached without everyone playing their part. And I think we all need to play our little part, put in what we have in our sphere of influence to make a positive change. I came to software engineering through an electronics engineering degree. As part of an engineering degree, we do a course on philosophy and ethics. Now, this is very important in engineering. You don't want a civil engineer to sign off on a bridge that's going to collapse and harm people. But I think in software development, we should have that same ethical obligation. We have an ethical obligation to make sure that what we create does not harm. And I think part of that is making sure that what we create has lower emissions to not harm the planet, which creates harm for people in turn. So, how is South Africa doing in these goals? These were created in 2015. We're now in 2023, a little past halfway. The short answer is not well. About a third of the goals were on track to reach, so by 2030. So that's good. A third, we're on track. Around a third of these goals, we've stagnated. We haven't made much progress at all. And unfortunately, on a third of these goals, we have worsened. Things have gotten worse than when we started out in 2015. So I really think that this is something that will take everyone doing their little bit. And if we can all work towards this, we can have a big positive impact in the world and in South Africa. So I'm going to start off just by talking about what is green coding. Now, this is a fairly new term. The first reference I can find to it is around 2018. I couldn't find any big official definitions. I found lots of varying definitions. So I decided to put together all these different definitions into my own definition of green coding. So green coding is an environmentally sustainable computing practice seeking to minimize the environmental impact of software. So it's a practice, it's something we do in our day-to-day lives when we create software, and our goal is to minimize the environmental impact. This is a more wide-reaching goal. This is not to want to minimize something very specific. We want to minimize the environmental impact that our software has. So a question you might have is, well, what impact does our software have? Software development is responsible for around 4% of global emissions. Now, that might be difficult to put into context. What does 4% mean? That sounds very little. The entire aviation industry, now, if you think of the aviation industry in terms of environmental friendliness, these are the people who are often vilified in the media. These are, whenever you look at an article, you see advice about taking trains instead of flying, about the huge emissions that aircraft create. The entire aviation industry is responsible for around 4% of global emissions, around about the same as software development. So when we think about the impact software development has on the environment, we can think about it in terms that it has about the same impact as the entire aviation industry. So I want to talk about the elephant in the room. Python is not known to be a high-performance language. But I think we're going to talk about performance now anyway, because it is important, and because I think we can create performance services in Python. But also, hopefully through the rest of the talk, I can show you that the fact that Python is not known to be this high-performance language does not matter that much. We do not all need to change this to a Rust conference. So, first, I want to talk to you about what is running. And when I talk about what is running, I'm talking about the code that you're writing that is running. And how do we have a look at that and improve the performance, reduce the environmental impact that it has. Now, I'm using performance and environmental impact here interchangeably because most of the time that is true. The more performant your code is, the quicker it can run, the more the CPU can go back down to sleep states, the less energy it uses, which means there's less emissions to generate that electricity. So first, and the most important thing, is to measure. You want to measure for two things. You want to measure so that when you make changes, you do not make the situation worse. You want to make things better, and to know that, you need to measure before and then measure after the change and make sure that you're making a positive impact. And the second one is you want to measure where your software is spending the most time. Because if you know where it's spending the most time, you can target that first. And by targeting that first, you can have the biggest impact in speed-ups. So across all these topics, measurement is very important. You need to know where you want to make that impact, and you need to make sure that you are making the impact that you think you're making. Secondly, you want to look at algorithms and data structure. I think making sure that you're using the correct algorithms and the correct data structures for the job is much more important than any little tweaks and changes and small performance impacts that you're trying to make. You're trying to change the way this code is structured to get more performance, but if you're using the wrong algorithm, you're having a very minor impact where you could have a big impact. For example, if you have a large list in Python and you're often inserting into the beginning of this list, that is an own operation, you might be better served using something like a double-ended cube, where it's an O1 operation to insert into the beginning of that. So now you've measured the impact, so you can make sure your changes are having a positive impact. You've made sure that you've chosen the right algorithms and data structures. But often we just need to do computationally expensive things. We're using the correct things, and there's no way to improve it. And I think the next step you want to look at is caching. Now, be careful with caching. Caching can cause a lot of issues, a lot of bugs. I've caused a fair few myself by adding caching. But for expensive calculations, sometimes caching is the only choice. So be careful with it and use it in the right situations, but it can make a big difference in the correct place. Next, I want to talk about libraries. Now, libraries can really help us get around that whole Python is slow image. When you're using things like NumPy and pandas, a lot of the number crunching work is running in a faster, running a faster language. Firstly, it's compiled language, but also a lot of effort and work has been put into optimizing those algorithms that are being used. So by using those things, you are using a very optimized version of an algorithm. So if you're doing a lot of heavy number crunching, this can have a great positive impact to your performance. And then lastly, I want to talk and give a shout out to PyPy. I don't know if a lot of you know or have heard of PyPy. It is an alternative Python interpreter, alternative to the normal standard CPython interpreter. It is a Python interpreter written in Python, which does not sound very performant, and I won't go into the details of how they make that work. But in a lot of use cases, and yet again, measure before and then measure after PyPy. But in a lot of use cases, it can give you a big speed up. It is very compatible with a lot of Python projects and works especially well when you're doing a lot of pure Python work. So give it a try. It probably works or works with minor changes and can give you a big speed up for not much effort. So this is a very high-level overview around improving the performance and therefore the environmental impact of your code, the specific thing that is running. We can go and have hours of talks and discussions around this. But I want to give a shout out to pythonspeed.com. There's a lot of great articles on there around getting the most performance you can out of Python and common issues and things that you might run into. You get my lovely drinking sounds there. Okay, next I want to introduce a new term, embodied energy. So when thinking about the emissions, often we're thinking about the energy required to, say, run this laptop. But what we're not thinking about is the energy required to create this laptop. To create this laptop, we need to mine raw materials, we need to smelt and process them, we need to assemble them, we need to transport them. All of that goes into creating this laptop. So often there's a trade-off between the amount of energy required to run something versus the amount of energy required to create something new that is more energy efficient. So the definition of embodied energy is the sum of all energy required to produce goods or services. So we're looking at a holistic view of what all did we need to put together to create the hardware and the service, not just what we need to keep it running. So this moves us over to where is it running. And I think when we're talking about where things are running, we must keep in mind that it's not only, if you're creating a web service, for example, it's not only the servers that require energy, it is the user's device who is using your service that require energy. So for this example, I'm going to have a look at the energy usage of me sitting on my couch watching Netflix. So in this case, the data center uses around 6 watts. That's about 6.4% of the total usage. The network here uses around 18 watts. That's about 19.1% usage. And that kind of makes sense to me. You're streaming video. It's not a very server-intensive, compute-intensive task to serve that video, so data center usage is small, but these are large, high-definition video files, so the network usage, energy usage is high. But what is perhaps surprising is that nearly 3/4 of the energy, 70 watts, is being used by me and the TV that I'm watching it on. So this is often surprising and unintuitive, and I think we must always make sure that we're looking at what we're running on user devices as well as what we're running on our servers, because that can often have a big impact. And obviously this isn't true for all services. Some services might do a lot of compute in the data center, and people, if I was watching Netflix on my cell phone, that would have a very different view of this graph. So how does this translate into environmental impact, into CO2 emissions? So for this, I want to show you where it is running makes a difference not only between server versus user device, but where in the world something is running. So if I had to watch a Netflix show for half an hour, you can see in different countries that makes a big difference to the environmental impact. In South Africa, if I watch that show for half an hour, that's equivalent to driving around 175 meters in a car. If I was watching that in France, in that same car, using that same amount of emissions, that same car would only take me 20 meters. South Africa, unfortunately, has a very dirty energy mix, so our electricity has very high emissions. But I think it's important to think about where things are happening. And you can see that just because something takes so many watts of electricity does not mean it has the same amount of emissions. Now, if you're paying close attention to that chart's title, you might have seen I introduced a new term without telling you about it, CO2e, or carbon dioxide equivalent. Now, this is something we use to compare greenhouse gas emissions. For example, if you have two services, service A and service B, and you want to choose the one that has the lowest environmental impact, service A might release 1 kilogram of methane and 9 kilograms of carbon dioxide, while service B releases 1 kilogram of carbon dioxide and 9 kilograms of methane. And now you want to be able to compare these, but that's difficult. You could just say, well, I add the 1 and the 9 for both, and they're both 10, and therefore they're both equivalent. But it turns out that certain gases have a much bigger greenhouse gas effect compared to other gases. For example, methane has almost 30 times, 29.8 times the effect that CO2 has. So what we do is we normalize everything to carbon dioxide because we had to choose one, so we chose carbon dioxide, normalize everything to that, and so we take the amount of methane, multiply that by 29.8, add the carbon dioxide, and then we get the CO2 equivalent emissions for the service. Now, this is an abstraction. As with all abstractions, it's not perfect, but it does allow us to compare emissions across different processes, and that is very useful. So when, in the previous slide, we were looking at the CO2e. We were looking at all the greenhouse gases emitted during those processes equivalent as if they were all carbon dioxide. So when looking at where your code is running, these are AWS regions. These specific regions are using 100% renewable energy. Now keep in mind that's not taking into account the embodied energy, and this isn't a recommendation for AWS. AWS is just what we use at our organization, so I did the research into AWS. So these regions are running 100% renewable energy. So simply by hosting some of your, say, background running tasks, if possible, in one of these regions, you can reduce the environmental impact, the emissions of your service, and with not much, but not by making your services more efficient or faster, but just running them on cleaner energy. So AWS itself is committed to running on 100% renewable energy by 2025, net zero by 2040, and they're also looking at reducing their embodied energy. So that's great, and I'm sure other providers have similar things, but when choosing which provider you go with, I think this can also have a big impact. Some of us have a choice of where we run things, where we host things. And if you have that choice, most providers are looking to differentiate themselves on features or on costs. But by also looking at the emissions your service would have by running on these various different providers, and when you're talking to them, if you bring this up and ask them questions about that, this will show them that this is something that we care about, and therefore they'll put the the kind of energy and put the effort and the cost into making this one of their unique selling points, make us one. And hopefully this will become a thing that gets big across the entire industry. But we need to make sure people know that this is something that we care about, so that they can take that action and make that change. Now, greenhouse gas emissions are not the only thing we need to worry about when we're looking at environmental impact. So these are some headlines around almonds and the amount of water it takes to grow almonds. I don't know if you've seen any of these headlines, anything like this, but it's a big concern around the amount of fresh water that almonds take, especially in water-scarce areas. So emissions is not the only environmental concern we need to worry about. There's freshwater usage, there's habitat destruction, there's deforestation, there's ocean acidification. So I want to have a bit of an interaction here. So if you could hopefully scan this QR code for me and answer this question. I want to get a feeling of the intuition around this, so please don't look it up. Question is, we're doing this digitally instead of a hands-up thing, so it can be inclusive to people who are joining us remotely. So if you're joining remotely, please also scan this and give me an answer. So according to a meta-analysis study by the University of Oxford, how much more water does almond milk require to produce compared to cow's milk? Is it A, almost 4 times as much water, B, just under 2 times as much water, C, is it round about the same, or D, is it around about 60% of the amount of water? So we're looking at how much water does it take to produce almond milk versus cow's milk. Is it A, 3.9, B, 1.8 times, C, around about the same, or D, 0.6 times? Now, I hope that that's enough time for everyone. You're going to have to give me a few seconds because we do not have the technology to do live updating graphs yet. So I need to do this, update, there we go, and we go, okay, and, oh goodness, let's get, where's my presenter view, okay, there we go. So now we can make, okay. Sorry for the interruption. So we have, oh, that's a funky order. I'll read out the legend at the bottom, which is very small to see. So most people answered 3.9 times as much water, second most 1.8 times, third most 1, about the same, and the least amount of people answered D, 0.6 times. Now, this is a very interesting thing because this is very non-intuitive, or at least I think it is. Because almond milk uses 40% less water and 78% less carbon dioxide than cow's milk. The correct answer there was D. And what this goes to show is that often the intuitive answer when you're thinking around environmental impact is not the correct answer. Now, this is a trend that I've seen across a lot of research, that animal products use more drinking water, more land, more carbon dioxide, and cause more deforestation than the alternative. So even looking at the most intensive milk alternative, almond milk, we're still using 40% less water and 78% less carbon dioxide emissions than cow's milk. A quote from the author of the study is a quote from the lead author, Jason Poor, of the study, saying that a vegan diet is probably the single best way to reduce your impact on planet Earth. Not just greenhouse gases, but global acidification, eutrophication, land use, and water use. Just to explain a few of those terms, acidification, we're talking about when CO2 gets absorbed by the ocean, creates carbonic acid. This results in all marine organisms having reduced calcification, reduced metabolic rates, and a lowered immune response, and reduced energy. So not great for our marine organism. Eutrophication is when a body of water is over-enriched with nutrients, which increases algae and macrophytes. And so the reason I think the author said this is that there's a lot of things that we don't control. There's a lot of things that we don't have at least a direct or even an indirect control of. The electricity that we're using here to run this conference, we don't have a lot of control over ESCOM. Otherwise, I'm sure we all have our opinion of what we do differently. But we cannot create it. Most people do not have the choice to have greener energy and to install solar panels and all of that. Coming here today, there's no high-speed train I can take here running off green energy. I have to take a flight. There's a lot of things we don't have a choice of, but when you're looking at the population as a whole, a lot of the main thing that people do have a choice of, or a lot of people have a choice of, is what they eat. And animal agriculture is responsible for 91% of deforestation. A plant-based diet is estimated to reduce CO2 emissions by 8 billion tons a year. That is a 20% reduction globally of the entire greenhouse gas emissions by switching to a plant-based diet. So why I'm saying this is we're transitioning over now into who is creating this. So we're talking about the people that create the software and how they get to work, what they eat. And so simple things are like in your office, replacing the kind of milk that is used in the office can have a big impact into the effect that creating the software does. So when we're looking at this, as I said in the beginning, the most important thing to do is to measure, and I'll go through each of these so you don't need to be able to read the very tiny text at the bottom. We want to measure or at least estimate where the most emissions are so we can target those first to be able to have the biggest impact. So these are emissions by sector. Blue is South Africa, red is global average, just to have something to compare about. The big one on the left is the electricity and heating. This, to me, is a little surprising because most of South Africa has a temperate climate. We don't need to heat our homes for half the year to not die. But this kind of just shows you how dirty the grid is. And so the only way that we can really improve this within our control is to reduce the amount of electricity we use. If you work in an office building, often the biggest energy use is climate control, the air conditioning, cooling, and heating. So maybe we could do things like have a look at the dress code, if there's an enforced dress code, by allowing people to dress more comfortably, to dress according to the temperature as outside. Maybe we can not use the cooling or heating as much. And that can have an impact on this biggest one here, the amount of electricity we use. Also looking at the amount of electricity that our servers, the users' devices use. If we can reduce that, that is the biggest one, at least in South Africa. Second one is transport. Transport, I think what we can do there is have a look at work from home, remote working. Now, remember what I said, it's important to measure or to have a look at estimate. So don't believe me when I say work from home reduces emissions, because there are economies of scale at work. There are certain things that if you do it for everyone in the office, you can do it with less energy than everyone doing it individually in their own home. But having a look at the studies on this, work from home definitely does decrease emissions. Yeah. Next one there is manufacturing and construction. Now, manufacturing and construction is a big thing that encompasses a lot. So obviously, work from home, if you can reduce the amount of office buildings, that reduces the amount of construction we need to do. But also, sneakily inserted in here, is the creation of fertilizer, which is a big one. So diet, I think, and what we eat can also really play a role in reducing the emissions under manufacturing and construction. Next up is fugitive emissions. This one, at least in South Africa, I would lump mostly with electricity and heating. Fugitive emissions are things like leaked methane from when we're mining and extracting coal, and also intentional and unintentional leaks from oil processing. So this kind of goes under electricity, heat, and transport. And then the next ones there are buildings, which we discussed already, agriculture, which is mostly around diet and choose what we eat, can make a big impact there. And then the rest of the smaller ones are ones I think we have less impact, at least through our work, through software engineering, things like waste. We can look at recycling, reusing, composting for that. There's industry, there's aviation and shipping. Note that that's quite far down. There's other fuel combustion, and the last one there is land use change in forestry. So hopefully that gives you an idea of when we're looking at who's creating it around the office, maybe it gives you some ideas, some things I haven't thought about of where you want to focus your energy, time, and efforts, and how you want to address that. So I just want to give a quick summary around what we've covered. First, we looked at what is running. Remember to measure, must measure before and after, measure to know where your code is spending the most time. Then we'll make sure that you're using the correct algorithms. This, I think, can have a much bigger impact in a lot of services compared to other changes you can make. And also give PyPy a try. Then, when we're looking at where, we must remember not just the code that's running on servers, also the code that's running on user devices, and also having a look at server regions, providers, where that energy source comes from, and also remember about the embodied energy when you think about buying hardware, replacing hardware. And finally, we're going to look at who is creating it. Here, it's often very difficult to measure. So as you've seen me do, we estimate. We have a look at studies. We have a look at the results that they came up with there, and then we apply that to our own measurements. We have a look at the emissions of watching Netflix and say, okay, well, I watch Netflix for 2 hours, and therefore I can do some maths and transfer that over. So we look at the stats and estimate the environmental impact there. And we will start with the biggest impact that applies to all these. Start with the biggest impact, see what you can do there, and work your way down. All right, I hope I've managed to at least teach you something. Thank you very much for listening.
Thank you, Rudi. That was very interesting, very informative. Not often we get a talk on this kind of topic, so fantastic, thank you. There has been a whole heap of conversation on Discord, mainly ESCOM jokes, frankly, but that's the kind of thing you expect in South Africa. Do we have any questions from the floor? James? I was going to repeat your generator joke, so I thought you might do it.
I only use a joke once, Kim. You spoke earlier about like data center regions. If your server is running in Iceland, then it's entirely geothermal or whatever the case is. But you showed in the earlier pie chart that the network actually accounts for a much bigger chunk than what you might expect. So if you decide to run in a green data center, have you tried to estimate that, like compared with? So I mean, the network from here to Joburg is much less than here to wherever in the world.
Yeah, so that's something where I cannot give you, where I said in the beginning, I cannot give you an answer. I am hoping to give you tools to be able to work out for yourself, because we can't say, for instance, that running in a different region will be the better option for you, because, as you said, there's that network impact. If to be able to run in a different region, you need to transfer a huge amount of data over the network and then do some minor calculations, it will probably be more efficient to run it just on the servers you're normally using. But yeah, so it's something you need to have a look into if you're doing a lot of heavy number crunching on a relatively small amount of data, and legally and responsibly you can do it, process it somewhere else, then maybe moving the data over the network, processing, and then moving the results back does have a lower impact.
Anyone else? Questions? Hands? Microphones? Yep.
Thank you for your talk. I come from a HPC background, so obviously optimizing code is key. One of the things you spoke about is measurement. So I'm not sure if you know about the scaling profiler, which allows you to give you, for each line of code, if it's the CPU usage, memory usage, or GPU usage.
Yeah, so I've heard of it. I've never used it. I think things like that are important because, as I said, when you measure, you don't want to measure just the overall impact. You want to measure where your code is running to be able to, and that's one of the tools. There are multiple tools. I didn't want to go, we'd have a very long talk if I went into, I think using those tools is probably a whole talk on itself. So yes, thanks for bringing that up. Python Speed also has a bunch that they recommend. There's a whole bunch of these tools around.
Thanks. Benjamin, up at the back there.
Hi, thanks for the talk. I have a question in particular with respect to, if you have a business, for example, you have a large business, a large corporation, there are certain budgetary constraints that don't exist with respect to a smaller business, a smaller company. And those things have an impact as to how do you code and how do you consider certain things. So do you have an HPC available to you? Is there, would that, for example, say for a bank where all the resources are made available for someone, would there be much relevance to actually convincing them that these methodologies still hold weight for them, considering the fact that they say we're going to provide whatever we can for our employees as long as we can just get the job done. Is there that sort of consideration for this? Because at the end, you always have to say, well, is this actually going to be applied more than anything else? Thanks, mate.
Yes. I think talking about the kind of sphere of influence you have is important. If you don't have influence over something, often there's a lot we don't have a choice in. Then there's nothing much we can do. But what we can do is talk about these things. What we can do is kind of say, we are professional. As professionals, we think that this is the ethically correct thing to do. We do not want to do this. And you can talk about these things and make it known and kind of do the research, do the calculations, and see what impact you can have. Now, and so if this is something that you have no impact on, I would say don't worry about it. There are other ways, other things you can do to make an impact. So focus on what you can have an impact on. Focus on the kind of the little ways that you can have an impact. But I think having a look at if there's resources available, whether those resources are used or not can have an impact. Modern CPUs, for example, are very good at scaling down to very low usage when they're not being used. So the power difference between using them, not using them. So I think even if you have a large amount of resources available, making efficient use of those resources is important as well.
Thanks. We'll take one question from online, and then I think we're pretty much out of time. So a question from Gordon, which I've lost. Thanks for the great talk, he says, which is not the question part. Do you have some rules of thumb about software scale? Say per 10,000 mobile users that cause 1 second of a single thread to run, and maybe to compare that to something in everyday life, say emissions of driving a car 100 kilometers, or something like that, as yours.
I don't have that offhand, but it is something you can calculate. We need to look at the energy usage. But as I say, that can vary depending on where you're getting your energy from, things like that. So it's wildly variable. So I don't have a rule of thumb because these things it can have a very small, very big impact. So I think it's important to measure it for your specific circumstance and have a look at it that way. Yeah.
Perfect, and that brings us to exactly 10:30. So we shall call it there. Thank you very much, Rudi. Fantastic keynote. Thank you very much.